We have been talking about bonding in compounds. In the previous chapter, we talked about ionic bonding, and many of you have mastery with naming and formula writing ionic compounds. Some of you need a little bit more practice. You'll get your quizzes back today. You need to go over them very carefully. In this particular chapter, we're talking about covalent compounds, which are formed through the sharing of electrons, and we're going to take a closer look at that sharing of electrons today as we learn how to draw the compounds. We're going to draw compounds today that have single bonds. We'll get into multiple bonds next time, and we'll start to construct the compounds in the lab, and then we'll also talk about shape and polarity. I'm saving the naming and formula writing for first thing next week. It's very, very easy, much easier than ionic, so I know you will do extremely well with it. And what we're first going to introduce today is how to draw compounds. Before we do that, there is some terminology that I want to go over. Then we'll go over the rules for drawing compounds. We'll draw some together, and by next time, you should feel pretty confident drawing these compounds. First thing we want to do is go over some terms. Their definitions are here. I'm going to draw you some examples so you can better understand what these terms mean. The first one is molecular formula. The molecular formula is the chemical formula for a covalent compound. It's going to tell you how many atoms make up the compound and how many of each you truly have in the compound. So in the three examples shown on the board, what you're seeing here are three different molecular formulas. And again, HCl, you know you have one H and one chlorine. CH3Cl, one C, three H's, one Cl. C2H3OF, you've got two carbons, three hydrogens, one oxygen, and one fluorine. The molecular formula tells you which atoms comprise the covalent compound and how many of each you have. The skeletal structure simply shows you the arrangement of atoms, and I'm going to show you how to determine a skeletal structure in about 10 minutes. But all it shows you is the way the atoms are arranged. So if you only have two, it's easy. They're side by side. In this one, I will show you how to determine which atom is in the middle, or referred to as a central atom. And then in this one, you'll also see how to figure out which atoms, in this case, are in the middle Ooh, I stuck bonds in there. I'm so sorry. Structural formulas don't have bonds. So just the skeletal structure shows you the arrangement of atoms. So that would be the skeletal structure. The structural formula not only shows you the arrangement of atoms, but it shows how they're linked together. There's my single bond, as well as lone pairs of electrons on atoms. The structural formula shows you how the atoms are linked together, as well as lone pairs of electrons. We'll go through some of this. And again, the structural formulas are going to connect the atoms according to certain rules that we will go over. As such. So those are the structural formulas. They not only show you the way the atoms are arranged, but how they're linked together. Remember that a single stick is a single bond, one shared pair of electrons, as we talked about last time. a double bond. 2 sticks is 2 shared pairs of electrons. And these electrons here, those are called lone pairs of electrons. They're not shared between atoms. They're on a single atom. Other terms that you want to be comfortable with include central atom. A central atom is connected to at least 2 atoms. So for example, carbon here is connected to 1, 2, 3, 4. So highlighted in yellow would be the central atom. Typically, the central atom has the lowest electronegativity value, although there are exceptions to that rule. Atoms that only link to one other atom, that is the atoms at the ends, are referred to as terminal atoms. When somebody is terminal, they are nearing the end. And that is a terminal atom. One thing to make note of right away is hydrogen must always, 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 always be a terminal atom. Hydrogen will never be a central atom. Typically, the atom with the lowest electronegativity is central, but be careful. Hydrogen will never be central, and for your purposes this year, halogens also will only be terminal. So that's just some terminology that we didn't get to last time, and you'll see it all come into play today. There are a number of rules to consider when drawing compounds, and we're going to go through those rules as well as how to draw the compounds. It takes practice. Some of the rules won't make full sense until we've actually drawn them, so give it a chance. Don't panic. I promise you will be very successful with this type of analysis, provided that you put the practice in. So in regard to the rules, I mentioned the first one already. Hydrogen will always be a terminal atom. Always, 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 always. For your purposes this year, halogens will always be terminal atoms, and each of these only forms one single bond. Typically, the atom with the lowest electronegativity, you're not going to use a halogen and never a hydrogen, will be the central atom. These atoms typically have fewer than 7 valence electrons, and they can form single, double, and or triple bonds. Great central atoms include carbon, nitrogen, phosphorus, oxygen, and sulfur, although some of them can be terminal as well. When placing valence electrons around an atom, you will always, always, always put one on each side before pairing. You have to obey Hund's rule, as we talked about the other day. The new rule is right here. The first electron must be placed between 2 atoms, and I'll show you how to do that. Nonmetals of the second period, except boron, and beryllium, tend to form the number of covalent bonds equal to 8 minus the number of valence electrons. I'm going to throw beryllium in there too. 8 minus the number of valence electrons. So let's think about it. Halogens are in group what? 17. How many valence electrons? 7. 8 minus 7 is 1. Halogens typically form one single bond. Highlighted in yellow is what you'll typically see this year. Carbon is in group 14. How many valence electrons? 8 minus 4 is? Nitrogen group 15. 8 minus 5 is? 3. That's how many bonds typically forms for period 2 elements. Oxygen group 16. 8 minus 6 is? 2 bonds. Sulfur, same group. Phosphorus, same group as nitrogen. Now boron and beryllium are a little bit different. Boron's going to form 3 bonds, no lone pairs. Beryllium will form 2 bonds, no lone pairs. You won't see very much with beryllium. You'll see a little bit with boron. These are the steps for drawing compounds with single bonds. We'll get to the multiple bonds next time. You have to master single before multiple. The first step in drawing a Lewis dot structure or a structural formula is to figure out the total number of valence electrons in the compound. Very straightforward. I'll walk you through in a minute. Then you're going to draw the skeletal structure. That shows how the atoms are arranged. Keep in mind the atom with the lowest electronegativity typically goes in the middle. Place the valence electrons adhering to the octet rule and Hund's rule. There are some exceptions to the octet rule: hydrogen, boron, beryllium, and the noble gases. The ones you will see the most of are hydrogen and boron. Make sure your valence electrons check out. Change shared electron pairs to lines to represent single bonds. I'm going to walk through steps A through E. As we draw these compounds out, we'll draw as many out together as we need, and then you'll be ready to fly on your own. Not difficult. Highly recommend either highlighters, colored pens, or colored pencils. If you need colored pencils, I have them in the back of the room. You are welcome to pick up 3 or 4 so that you can draw these out. Alright, we're going to walk through very carefully. Bromine is the molecular formula, Br2. We want to figure out its structural formula, and we can do so in a series of simple steps. The first thing we want to do is we want to determine the total number of valence electrons. I'm going to label this A for step A. I have 2 bromine. Bromine's in group 17 and therefore has 7 valence electrons. 2 times 7 is 14 valence electrons. Next, I'm going to draw the skeletal structure. Well, if you only have 2 atoms, you would just put them side by side. Next, I'm going to put the valence electrons around. I'm going to include this in the same one. I'm going to use different colors. The first valence electron must go between the two atoms. Look up at the board. 1, 2, 3, 4. Now you have to pair, but you don't pair between the two. 5, 6, 7. You right, Stephen? Yeah. Okay. You're going to do 7 for the other bromine. The first one goes between 1, 2, 3, 4. Now you have to pair. Don't go back between. 5, 6, 7. My next step is a count. Doesn't matter where you count starting, where you start to count, just be consistent. I typically go top, middle, bottom. Look up. 2, 4, 6, 8, 10, 12, 14. And that's the same count I had previously. That's a good sign. Where I have 2 different colored dots, I have shared pairs. Where I have the same color, I have lone pairs. I'm going to change shared pairs into sticks. I have 1 shared pair. Here's my single bond. And I must keep those valence electrons, those lone pairs of electrons, so that I have 14 valence at the end. The stick will be 2. So I have 6, 12, and 2 is 14. This is my structural formula for bromine. The other thing I want to mention is the reason why compounds form. Yes, I'm sorry, go ahead. The line in the middle represents the shared electron pair that was between the atoms where you have 2 different colors. The reason why compounds form, the reason why ions form, is so that you will have an octet of electrons around an atom or an ion. An octet of electrons confers stability. So looking here, it's going to seem like I'm double counting, but around each bromine atom is 2, 4, 6, 8, an octet of valence electrons. 2, 4, 6, 8, an octet of valence electrons. That's why compounds form, that's why ions form. Questions on the first. If you follow these steps, you'll be highly successful. Now, as we draw a few and you have a better comfort level, I'm going to show you how to skip a few steps, but there's one step you never skip, and that's the number of valence electrons. Otherwise, you're going to leave out some lone pairs and your structure will be wrong. The next example is hydrogen iodide. This is its molecular formula. We want to get to the structural formula, which will be shown in step E. The first step is always to count valence electrons. Hydrogen's in group 1. It has 1. Iodine group 17, it has 7 for a total of 8 valence electrons. I'm going to put the atoms side by side. When you only have 2, it's pretty easy. The next thing I'm going to do is put my valence electrons in. The first one always goes between. Here's hydrogen's valence electron. Here comes iodine, first one between. 1, 2, 3, 4, 5, 6, 7. And in step D, I'm going to do an electron count. 2, 4, 6, 8. That's a good sign. Note the octet of electrons around iodine. Hydrogen only forms a duet, so it will only have 2. Keep in mind, hydrogen will always be a terminal atom. 1 single bond, no lone pairs on it. The last thing I do is what? I'm going to change the shared pair to a line, which also represents a shared pair. And don't forget those lone pairs of electrons. Now what you're going to see this year is that the halogens will form 1 single bond and have 3 lone pairs. 1 single bond, 3 lone pairs for this year. Hydrogen forms 1 single bond, no lone pairs. All right, let's try another one. I'm going to ask you for more of the steps now to make sure you're understanding. That's the molecular formula. What's the first step? Count the electrons. You got it. Carbon has 4 valence electrons, 2 hydrogen, each with 1, 2 chlorine. How many valence electrons for chlorine? 7. It's in group 17. So we have 14, 16, and 4 is 20. What's the next step? Huh? Right, you're going to put the letters where you think they belong, and that's called a skeletal structure. Now, we know that hydrogen can never be central. For your purposes this year, halogens aren't central either. What's the central atom? Carbon, and that's a great central atom. There's my skeletal structure. Typically, the more electronegative atoms will be placed as far apart from one another as possible, but if you had interchanged these two, that's okay. What do we do next? Valence electrons. Carbon has 4, 1 on each side. 1, 2, 3, 4. Hydrogen has how many? 1. And what does chlorine have? First one always goes between. Then you double up, but you don't double up between. Be careful there. First one between. What's the next step? We're going to get a count. Again, go top to bottom. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You'll note that all the elements except the hydrogens have 8 electrons around them, that octet of electrons. That's why compounds form. And what's your last step? You're going to change shared pairs to sticks, but don't forget those lone pairs on chlorine. Yes?
Would it still be right if the hydrogens were, or do the hydrogens run on the top?
Yeah. You just mean spin it?
Yeah.
Yeah.
Okay.
Some kids like the dots. Some kids say the dots drive them nuts. As you get better at this, you can go directly from here to here to here, and I'll show you that.
What if there's more than one element that can be in the center?
Do you mean what if you have something like this?
Yeah.
Right, and we're going to get to that in just a minute. Yeah. What I want to just show you briefly is instead of doing all the dots, some kids like to go sticks right away, which is perfectly fine. It's certainly what I do. I just want to make one suggestion. If you had your molecular formula and you determined number of valence electrons, once you got your skeleton or skeletal structure down, instead of putting dots in, how many bonds does carbon typically form? 4 is correct. It has 4 valence electrons. 8 minus 4 is 4. You can see that there are 1, 2, 3, 4 atoms attached to the carbon. So you could put 4 bonds in already. You know the hydrogen forms 1 single bond, no lone pairs. And what you're going to see again and again and again is that the halogens form 1 bond and have 3 lone pairs. Be sure to complete the octet for the element. And without doing all those dots, you can go directly from here, here, and the skeletal structure right to the structural formula. And I'll show you a couple of those direct for those of you who want to bypass all the dots. And then this, Amanda, I think is your question. In the next example, we have a molecular formula of CH3OH. Take a minute to find valence electrons, CH3OH. What'd you get, Halen?
What? I'm sorry,
Oh, you can stand up if your legs are stiff, but just focus. How many valence electrons? 14 is correct. You can combine those H's if it's easier.
Because there's 2, 6, and there's 4 ones.
Now, Amanda, I think this is your question. How do you know if you have more than one central atom? Or is it, how do you know what should be central?
Like, how would you draw the skeletal thing if there's 2?
Okay, so that's right here. Now, sometimes the way the molecular formula is written signals that the H's are going to link to the C's, or in this case, the 1C. So you know hydrogen can't be central, so you're thinking C is central, and there's going to be 3 H's on the C. You know the other H has to be terminal as well, and perhaps the O is the other central atom. In addition, typically your lower electronegativity elements are central. This one's kind of murky because H has the lowest electronegativity, but you know that H will never, ever, 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 ever be a central atom. We'll try it both ways now. Hydrogen. Let's do carbon first. How many valence electrons for carbon? 4. 1, 2, 3, 4. hydrogen, 1, 2, and 1 over here. How many does oxygen have? 6. 1, 2, put them both between first, 1 on each side. 3, 4. Now when you double up, you can't double up between atoms, so you're going to double up on the top and the bottom. And hydrogen's other valence, 1 valence electron is right there. Get a count. 2, 4, 6, 8, 10, 12, 14. That's a good sign. And what's the last thing you do? You're going to change shared pairs, which show as 2 dots, to sticks, which is still a shared pair. But don't forget your lone pairs on oxygen. And you'll see oxygen and sulfur for this year, typically 2 bonds, 2 lone pairs. Now for those of you who want to go to the structural formula a little more directly, that is perfectly fine. If you wanted to do that, you want to watch for the following. Go ahead and connect, but don't forget to complete the octet on oxygen, and that's why that count is so important, especially when you get into compounds that have expanded octets. Will, you have a question?
Yeah, how do you know how many lines you put? Like if it's double or single bond?
Right now we're just doing singles. We'll get into doubles and triples tomorrow. And you'll see with a double, for example, you'll have a lone electron that has nothing to pair up with. And so you'll have to move it so it can pair up with something. And you'll see that next time, or I can show you at the end if you're dying to know today. I'd be happy to show you. The other little trick I want to give you, and then I'm going to let you try too, and I've got some classwork for you to try. But what you're going to see for this year, when you get into AP Chem, Advanced Chem, the rules change. But for this year, what you're typically going to see is your halogens are going to form a single bond and have 3 lone pairs. So chlorine, for example. What you're going to see for this year with group 16, and I'm speaking mostly of oxygen and sulfur, is you're going to see 2 bonds and 2 lone pairs. Or you could have 2 bonds, 2 lone pairs. And for group 15, this is primarily going to be nitrogen and phosphorus. I'll illustrate nitrogen. You're going to see 3 bonds, 1 lone pair. You could have a double and a single and a lone pair, or you could have a triple and a lone pair. And that framework will help you as you try to decide on your compound drawing. This will make more sense when we get into double and triple bonds next time. But there's a couple of helpful hints. And what I would like you to do is to try and draw the last 2 compounds in your notes. The last 2 compounds in your notes are here on the screen, highlighted in yellow. I'll draw them on paper and we can compare. I can tell you what your classwork is that should be done for tomorrow if you really want to understand the multiple bonds. Only look up if you finished. I didn't show you yet because some of you looked up. But if you finished both, you want to look, see?
Yeah.
How did we do? Good. Picture of what? What your classwork is?
Yeah.
Sure. So how do we do here? This is ethane.
How does these connect? Like
How?
how do they? I thought they were just like this could be.
I think they're like both carbon. So they're both like.
What?
Aren't they like just one colored oxide the same?
Yeah, because it was the same colored dot.
So what you had with your dots, I'm going to draw yours below, okay? Otherwise it's going to be too squishy. Oh, did you always use the same color for the same atom? Is that what happened?
I used different colors.
Okay, hang on. 1, 2, 3, 4. If you don't have different colored pens, you can use a different shape. 1, 2, 3, 4.
That's pretty
And then each hydrogen is 1. You can use open circles, closed circles, whatever rocks your world is fine.
Okay, that makes sense.
So do you see the shared
Yeah.
pair here now?
I just thought that if it was the same like element, that it would be
The same color, okay.
Yeah.
Yeah, no. Yeah.
I got it.
All right. Hopefully you're getting a feel for drawing. Like everything else in chemistry, it requires practice and a lot of it. Your classwork, number 1, dealt with the electronegativity differences and the different bond types. Number 2 is on drawing. Only do A, B, E, F, and G, because the other ones involve multiple bonds, and we haven't covered that yet. I'll show you how to do that tomorrow, and you will get a lot of practice tomorrow, and we will get you into the lab drawing compounds, building compounds on Wednesday and Friday. And that will help you a lot, and we'll get your other lab done as well. On your desk should have been your project. I would like you to read it over, and I will go over it with you tomorrow. But I want you to read the directions first rather than me just reading it to you. We have a few more minutes before announcements come on, so if you have any questions, please don't hesitate to ask. Hopefully you're beginning to understand how to draw structural formulas for compounds, at least those that have single bonds. We'll get into multiple bonds next time, draw them, and then we can get into the lab and you'll be able to build your compounds. For those of you who like to play with Tinker Toys, this will be a dream come true for you.